Welcome back, everybody. This is AP Chemistry, the last section for Unit 8, taking a look at the pH of polyprotic acids. And what that means is it has multiple hydrogens along the way. And so when we do that, we have to account for each and every step of those along the way. Now, this particular problem, I only have one of these because they all follow the exact same procedures. So we just have to account for each and every one of the hydrogens along the way. We've got two different skills that we're going to be doing with this. And first of all is the one that we're really familiar with, and that's going to be the pH of things along with this reaction. So keep in mind with this, we are first of all taking that first step of creating the ice charts. This is going to dissociate into a hydrogen ion, and it's going to be making the H2PO4 with a negative H2PO4 with a -1 charge. Okay, so it's just dissociating, getting rid of one hydrogen along the way. When I look that up, I'm going to be seeing my Ka value ends up being 7.5 times 10 to the -3rd. Okay, I looked up that value. It starts at a 5 molar solution, so 5.00 molar, and we start out with 0 of this and 0 of this. Okay, so that's my initial. My change is going to be minus x. And at equilibrium, then, it's going to be 5 minus x and x and x. Now, remember that my Ka was given to be 7.5 times 10 to the -3rd. That's going to equal x squared over 5 minus x. Now, this is pretty big in there, so I would have to account for my x. My x ends up being 0.194. Okay, and so if I plug that in, my pH is going to be the negative log of the 0.194. Okay, pH of the problem would be a 0.712. Okay, so pretty low in there, and because it's a pretty strong concentration. Okay, now that's the part where it's asking about the pH. Now, the real trick with all this, the real point of this whole part is finding that concentration of each step of this process at equilibrium. So what did I have? I had my x ended up being a 0.194. So 5 minus a 0.194, that ends up being a 4.81 molar solution. Okay, at equilibrium, my H2PO4 ends up being the 0.194. Okay, so that part is taken care of. We've found this to be a 4.81. We found this to be a 0.194. Now, we have to keep going and asking for these other two. So we've got to keep going with our equation, don't we? So let me take a look at my H2PO4. That's going to dissociate and break down into a hydrogen ion, and my HPO4 -2 now. Okay, and if I look that value up, my Ka value of the second round is going to be a 6.2 times 10 to the -8. Again, I just look up this value. Okay, so my Ka ends up being my hydrogen times my, this isn't phosphate, it's hydrogen phosphate, and that's going to be over my H2PO4 concentration. Okay, so if I plug my values in, but this time I want to solve for this, and I want to find that concentration, don't I? I don't know some of the values in there, but I do know this value. So if I want to find this guy right here, let's do multiply by both sides and then divide by my Ka. In other words, I'll end up with an HPO4 -2 concentration is going to be my H2PO4 times my Ka, and that's going to be divided by my hydrogen ion. Okay, again, what I'm doing is getting this guy by itself, multiplying by both sides, and then I divide by my hydrogen. Okay, when I do that, remember this was a 0.194, and this is a 6.2 times 10 to the -8. And let's see, this my hydrogen ion, because this guy is going to be the same, that was a 0.194 as well. So my HPO4 -2 becomes a 6.2 times 10 to the -8. No, yeah, okay, so 6.2 times 10 to the -8. which is weird because that's my Ka value, but that's what I get, 6.2 times 10 to the negative 8, okay? Because I'm going and those cancel each other out, okay? Now, let's go to the last step. The last step, now that I've found all those, now let's get down and get this last species with my phosphate. Okay, how did I get my phosphate? Well, I take my H, let's see, my HPO4 negative 2 is going to dissociate into my hydrogen ion and my phosphate. Again, I'm just removing one more of the hydrogens in there, aren't I? Okay, so if I'm going to derive this, same way, let's take that third round. Okay, here's my second round right here. So I'm going to follow the exact same process, and I'm going to get my hydrogen ion, and I'll get my phosphate ion, and that will be over my, let's see here, that'll be over my HPO4 negative 2. Okay, now again, let's get the phosphate by itself. Multiply both sides, and then divide by my hydrogen. Okay, I don't want to lose you guys in any of the steps here. My PO4 negative 3 ends up being my Ka, my third round now, times my hydrogen concentration, HPO4 negative 2. And that's going to be over my H plus concentration. So plug the values in. My PO4 negative 3 concentration is going to equal 4.8 times 10 to the negative 13. Okay, and let's see, that one I looked up, and then I have my 6.2 times 10 to the negative 8, and I have my 0.194 again. Again, that number came because my hydrogen ion was 0.194. So my PO4 negative 3, if I just take a look at that math, that ends up being 1.53 times 10 to the negative 19th. Not very much at all in that last species, is it? So what did we do along the way? Okay, once you look at it in this respect, it's a big old mess, isn't it? But what I did is I just took one hydrogen off each time, and I took that value, and then I took this value, and I took one more hydrogen off, and just keep plugging in the values along the way. And again, we have to derive this so that I got my K value, but then I want to get this guy by itself. So multiply by both sides, and then divide by hydrogen, and I'll get my math. Now I take that 6.2 times 10 to the negative 6, and that's where this value went in for this one. And I followed the exact same process. So just keep decaying down the way, and I think you guys will be finding, as long as you keep in track along the way of what that is from your equilibrium, I think you're going to find you're going to have no problems. All right, good luck with those.